Hello everyone. So we continue our discussion on NQueen problem solution. And in this particular slide, what is basically seen is it is 8 by 8 chessboard, and the objective is to place 8 different queens on this chessboard. So if you look at, just try to understand how we are basically trying to remember the solution. So how to remember this solution? Because if you try to by heart this, then it is slightly difficult. So if you check, I'm writing the rows and columns across each cell, and we have 8 queens, q1 to q8. Okay, so there are 8 different queens which are to be placed, and they are to be placed in this 8 different columns. So in the previous video, I have shown you the idea of 6 by 6 chessboard, in which we have the solution like 2, 4, 6, and 1, 3, 5. So there is a even cluster and there is a odd cluster. So if you check again for 8 by 8, it's a replica of 4 by 4. 4 by 4 is basically 16 cell, and 8 by 8 is nothing but it's a combination of uh, 4 different matrix of size 4 by 4. So that is equal to 64 cells. Okay. So now if you look at this solution, we have again applied the same logic that we have started with a even cluster, that is 4, 6, 8. And the basic difference between 6 by 6 and 8 by 8, that there will be 2 rows additional in this 8 by 8. Similarly, there will be 2 columns additional in 8 by 8. So since there are 2 rows and 2 columns additional, we will keep these 2 spaces after 4, 6, 8. So it's a replica of 6 by 6 solution. If you look at 6 by 6, we have 3 particular locations with even values of column and 3 particular locations with odd value of columns. So here also we have 3 particular locations of or even values of column. We are keeping these 2 values blank for the time being. And again, we write 1, 3, 5. So our solution for 8 by 8 will have 8 different position in this matrix. Okay. And we write here 4, 6, 8. Keeping these 2 position blanks, we write 1, 3, 5. And once you have written these 2 clusters, which are of uh, even and odd, then what is the observation? That you will only have one column available in the second, one place available in the second column, and one place available in the seventh column. So you can write here 2 and you can write here 7. And again, we come to the even odd cluster. So it is 4, 6, 8, 2 and 7, 1, 3, 5. This is the even cluster and this is the odd cluster. So in this way, you can find another solution for 8 by 8. Again, the classical example of circular linked list Q1, Q2, Q3. We end here, keep these 2 rows blank, and again start with the circular linked list, that is after Q3, 2 rows blank, okay, and go round and come to Q6, Q7, and Q8, and keep. Once you do this, and once you cross the cells which will be invalid after placing the queen, then you will be only left with Q2 and Q5. So one of the solution for 8 queen problem is 4682 and 7135. Now, in this particular slide, you will be able to understand the constraint logic. What is this constraint logic means? If this is a matrix, then once you place a queen in particular location, then the row will be invalid. Similarly, column will be invalid and the diagonals will be also invalid. We are trying to understand how it is possible to find out the invalid cells once the particular queen is placed in a particular position in the matrix. So for example, if you look at this matrix, it is of size 8 by 8, and we have placed one queen here. So obviously, if you look at this, this is 4 comma 5. That is row number 4 and column number 5. So once we say row 4 and column 5, it means it is I and J. So so no other position, like if I say 4, 3, it is not allowed because the 4 is common here. Or if I say 4, 7, also not allowed because 4 is common. And similarly, if I say 2, 5, not allowed because column is common here. So logically, this column and logically this row goes invalid. Now, how to find out the remaining elements of the diagonal? So if you look at the diagonal positions, I have marked them with a black color and red color. So red color is one diagonal and black color is one diagonal. Okay. So let me show you on this slide how this particular concept is implemented and what will be the formula for the implementation. So let me remove this. So I'm just drawing three columns here. One column, one position, my selected position is 4 comma 5, and I'm keeping it as I comma j. So now I have the remaining positions as if I take the black diagonal and if I take the red diagonal. So my black diagonal will be 1 comma 2, that is first row second column, then 2 comma 3, then 3 comma 4, then I have 5 comma 4, 5 comma 6, then I have 6 comma 7, and finally 7 comma 8. Similarly, my red diagonal will be 1 comma 8, then 2 comma 7, then 3 comma 6, then again I can have 4 comma 5, sorry, 5 comma 4, okay, because 4 is already used. Then I have 6 comma 3 and 7 comma 2 and finally 8 comma 1. So with one cell, so it is a 64 cell matrix. I am using one cell, so remaining 7 in this, remaining 7 in this, that is 14 are not allowed. Again 1, 2, 3, 4, 5, 6 in this diagonal, and 1, 2, 3, 4, 5, 6, 7 in this diagonal are not allowed. So once I place one position or once I use one position, then I am basically discarding out of 64, 27 locations. So if I keep this as k comma l, if I keep this as k comma l, then you can look at this. This 5 plus 4 is 9 here. If I add these two values, it is 9. And if I add all these values, take any position, if I add 6, 3 or 7, 2, every position is equal to 9. And similarly, if I subtract 4 minus 5, I'll get 1. And if I say here 1, 2, subtraction will be 1, subtraction will be 1. So this side there is a subtraction and this side there is an addition. So when you have plus minus concept, then in such cases you are allowed to use absolute concept or absolute operator. So if I keep this as ij, this particular row as I, this particular column as j, and if I keep this as kl, then my formula for discarding will be absolute value of I minus k will be equal to absolute value of j minus 1. Look at this. 4 minus 1, absolute is 3, and 5 minus 2, absolute is again 3. If I take 4 minus 7, then also 4 minus 7, then also the absolute is 3, okay. And similarly, if I take 5 minus 2, the absolute is 3. So this is a simple concept which allows you to find out once you place one particular queen in a position, at some position in the matrix, which positions of the matrix will not be available for remaining queens. That is the formula absolute value of I minus k equal to absolute value of j minus n. So this will allow you to first find out how many cells will be discarded. I hope you understood this idea. Thank you. We'll continue with this in the next video.